Hey, how are you all doing? It's good to be back teaching you guys, even though it's not face to face. We're going to try to make the most of it here. Um, Hopefully, we will be able to keep on moving and learning together, and within a week, hopefully, we'll see you face to face again. But for now, we're going to start with section 2-3, and some of you have these notes that I gave you before we went away there for Thanksgiving break. Some of you I didn't get to see, so you might want to print them out. I've attached it on Classroom, so you can print out the notes here and fill them in as we go through this new lesson. There are a few of you that still need to turn in your tests from section 2-1 and 2-2, so make sure you email me some pictures or get in touch with me because I've been trying to get in touch with you and, well, I haven't heard from some of you. All right. So anyhow, this is a very important lesson on factoring, something you learned in Algebra 1. This is the beginning of section 2-3, and we'll probably be on this for probably all week here. So factoring is very vital to helping you to solve quadratic equations. And quadratic equations, remember, are the type that have x squared as the highest exponent, unlike linear equations, which don't have x squared, they just have x. So what is factoring? And we'll go and review this monomial, binomial, trinomial stuff. So I'm going a little out of order, but that's okay. So factoring is basically it's dividing out common factors among terms. Okay, it is really reverse distributing is what you can think of it as. So and for a trinomial, it's really unfoiling. Okay, so you can think of it as unfoiling. Remember, you foiled binomials times binomials. Well, it's really unfoiling if it's a trinomial. So part of factoring is dividing out monomials, and monomials are simply like one term that several terms have in common. Okay, so for example, like 3x might be a monomial, or simply 5 could be a monomial. All right. Binomial, of course, is two terms, and we've multiplied some of those together, like 3x plus 2. We multiplied two binomials together, 3x plus 2 times like 3x minus 1. And a trinomial is three terms, okay? And when you have trinomials, you can't always factor, but sometimes you can, and we'll talk about that. But trinomial might be something like 3x squared plus 5x minus 4, and that might be factorable, it might not be, but if it has an x square on it, then there's a chance that you could factor it, and there are a bunch of different ways you can factor. So let me give you a quick comparison of something that's factored versus something that isn't factored here. Something that would be factored might look like 4 times 3x minus 5, okay? And something that is not factored could simply look at like, just distribute that in, 12x minus 20, okay? So 4 times 3x is 12x, and 4 times minus 5 is minus 20. That would be the non-factored version of it, okay? So you see what we do when we factor is we, well, reverse distribute, okay? And we could do that with trinomials too. Like, for instance, a factored form might look like x minus 4 squared, okay? Which, remember, that's equal to x minus 4 times x minus 4, all right? The non-factored form would be the trinomial. That's equivalent to that, which would be x squared and minus 8x, whoops, sorry about that, minus 8x plus 16. All right, so just remember, when you are factoring, generally speaking, you'll be using parentheses to show and indicate and rewrite trinomials as multiplication. All right. So what else you might think is weird here is I use these caret things, but that's just a fancy way to do exponents. All right, so of course you could also do exponents this way. But on a computer, it's easier to type with the caret key. So try to use the little guy and not the caret key, unless you're maybe typing up your homework or something like that. All right, so let's keep rolling here. So this is how you think when you are factoring in general. All right, so you want to kind of work your way down here and just think. Okay, the very first question you should ask yourself, is there a greatest common factor among the terms? Okay, so if you have, say, a binomial or a trinomial or even 4 terms, there might be a greatest common factor. Like for instance up here, 12x minus 20, the greatest common factor was 4. Okay, and so I could divide both of these terms by 4. All right, and so you always want to look for a greatest common factor first. Next, you want to see how many terms there are. Okay, if there are 2 terms, you really can't do much very often. The only thing that you could do is factor something called a difference of 2 squares. That would mean that the first term is a perfect square, such as 9x squared, because 9 is a perfect square, because 3 times 3 is 9. And x squared is a perfect square, because x times x is x squared. Okay, and the other term has to be a perfect square as well. All right, so 4 is a perfect square because 2 times 2 is 4. All right, now the key here is it has to be a difference of 2 squares. Not a sum of 2 squares, but a difference. What does difference means? So it has to be subtraction of 2 squares, okay? And when you factor this, it will always be the square roots. See, the square root of 9x squared, okay, becomes 3x. So you square root 9x squared to get 3x, and you square root 4 to get 2. All right, and then you have a plus sign and a minus sign when you are factoring this, because if you were to check this, okay, so how would you think we would check this? All right, to check this, you would do good old foiling, okay? So you can check by FOIL, all right? And if you notice, if we do foiling, the outside would be negative 6x, and the inside would be positive 6x. That's why there is no x term in the middle, so it's really 2 terms. And the reason why we need to have different signs is because you want to get a minus 4. In order to get a minus 4, you have to do a positive 2, positive number, times a negative number to give you a minus number. All right? For 3 terms, okay, there's a special case where it is a perfect square trinomial. And a perfect square trinomial is kind of like a difference of 2 squares, only you have a middle term, okay, that is related to these outside and in the first term and the last term. The middle term, so first off, it has to be perfect squares for the first term and last term, okay? So if you have a first term and last term that are perfect squares, the middle term has to be double, okay? It has to be double the square root of the first term, okay? So it would be the square root of whatever x squared is, okay? That would just be x. And the square root of 9 has to be the middle term. All right, and so this, once again, is just a shortcut. If you recognize this, you can factor this perfect square trinomial. And you see it would be 2x times 3. Okay, if you square root these, you get x and 3, and that gives you the middle term of minus 6x. All right, and it doesn't give you the minus part. You have to put the minus part in when you write how this factors, and this would factor into x minus 3, the quantity squared. Okay, because you would, kind of like before, you have to take the square roots of these perfect squares, and the sign in the middle is actually the same sign as of this. And once again, you can check it by foiling. X minus 3 times x minus 3 will give you this. Now, not all trinomials are perfect square trinomials. Okay, so in fact, this is a very rare type. If you see this, it will help you out sometimes. But mainly when you have a trinomial, you want to factor by trial and error. And so that's what we're going to talk about for the next 5 minutes of this video, is factoring by trial and error. Okay, so let's check out how to do that. All right, so if you have a trinomial of the form, okay, so it has to have the first term. It might not be a might be 1, okay, but it has to be an x squared term as the first term, okay? So if you order the terms from greatest to smallest with the exponents, it would be ax squared plus bx plus c, okay? Now these pluses could be minuses, so just be aware of that. And if you have something like this, you can factor by trial and error. All right, so I want you guys to pause the video here and read through these slides here. All right, and then we'll go through it and show you what is meant by it. All right, so take a second, pause the video right now. All right, so let me give you 3 examples of factoring by trial and error. All right, so first off, it's important to know what the signs tell you, so you can pause the video and read what the signs tell you here, I guess, again. All right, so if I'm looking at the signs, the second sign tells me that both signs are going to be the same here, if it's a plus sign, all right? Then you would go to the first sign and you see they're both going to be positive in this case. All right, so before I factor this, it's good to list out the factors that could be in these binomials. Okay, so what you're trying to do, remember, is reverse distribute. So you're trying to list out binomials that will give you this if you were to FOIL it. All right, so factors of x squared are simply x times x, okay? And factors of 12 are, well, let's see. Start with 1 and 12 first. So you got 1 and 12. So list out all the factors. 2 and 6. All right, 3 and 4. And it would be good to list the reverse versions of this, okay? So like 12 and 1, 6 and 2, and 4 and 3. I did that on this one because it's more tricky. I'll talk to you about that in a second. But anyhow, so what you want to do, of course, is put the signs in. We know they're both going to be plus, okay? In this case, they're both plus signs. And boom. All right. And so when the signs are both plus, okay, you have to think, okay, if the signs are the same, okay, same signs, think addition, okay, to give you the middle. So using your factors, okay, so I'm going to erase this so I can write it neater here with typing it. All right, using your factors, which ones do you think will give you 8x in the middle? All right, so first the x and the x terms always go first in these binomials, all right? But looking at these, okay, 1 and 12 won't give me 8. 2 and 6 do give me 8, all right? So I'm going to just show you what I mean here. You put 2 here and 6 there. And if you check this by foiling, you'll get what's above exactly. Now, you can't necessarily you can actually save some time, actually, by doing a nice little shortcut. It's called the rainbow check. Okay, so since you listed the factors right, the f and the l are taken care of. So you really just got to make sure you have the right middle term. So if you multiply the outsides and you multiply the insides and you add them up, guess what it is? Okay, you got 6x on the outside, 2x on the inside, it's 8x, and so it checks. Okay, so this is just the check here. But really, what you guys are doing is trying to figure out which factors work. And so this is your factored answer right here, x plus 2 times x plus 6. All right? All right, so I think I'm not going to be able to finish this all in one video clip, so I'm going to upload another one in a second with a couple more examples on it. So stay tuned for that. All right, see you in a few.